Changing temperature is higher, okay, this part is going up. For object S, this part must be lower, okay, because the product remains the same. For object Y, what happens? This part is nothing but lower. The change in temperature is less. So here this part must be less. So this part must be higher because the product remains the same. Because the heat provided is nothing but same. So for object X, what we consider the change in temperature is higher. That means delta T is change in temperature, that is higher. That means C part, that is thermal capacity, should be lower, so that the product is, that is Q, remains the constant. Okay, so we can say option number C is correct. It has a lower thermal capacity, or it is also called as the heat capacity, which is lower than the Y. So option number C can be correct. We are just using this expression. Q is nothing but P into delta T, where P is the heat capacity or thermal capacity and delta T is nothing but the temperature increase. Okay, so for both the objects, the product should remain same, that is nothing but Q, because the heat provided is same. Now we will see the question number 4. Which statement describes what happens as ice at 0 degree Celsius starts to melt to become the water? Okay, we know that this is nothing but the heating curve. We are going to melt it, so we are going to provide the heat to the ice. So this is the heating curve, and we know that whenever there is a state change, the temperature remains the constant. So this is the, we can consider, and whenever there is no state change, the object is in the purely one state, that can be solid, liquid or gas. There can be temperature increase or decrease. So here this first curve we can consider as the ice, where the temperature is increasing. The second flat line we can consider the ice is converting into the water. So this can be the melting curve. Now here this third curve you can consider as a water liquid state, where the temperature can increase. This curve you can consider the water is converting into the gas, where the temperature remains constant. Here this curve you can consider the vapor or gas, where temperature can increase. So which in the melting curve we can see melting line. This is the melting uh, process curve, and where we can consider the horizontal line or flat line, because the temperature should not change. Here you can see option number A, energy is absorbed and the temperature remains constant. So you can consider this is our correct answer. First option itself is the correct answer, because the temperature should remain constant and heat is continuously supplied. Okay, so the energy is absorbed. Energy is nothing but the heat. Second option is given energy is absorbed and the temperature rises. This does not occur, because in the particular process, melting, freezing or vaporization, condensation, temperature should remain constant. Option number C, energy is released and the temperature remains constant. So energy should not be released, because this can be the cooling curve. Okay, this our curve is a heating curve. Okay, in the question number 1 we had seen the cooling curve. This one is a particularly heating curve. Option number D, energy is released and the temperature rises. Both are incorrect. Energy cannot be released and nor the temperature rises. Then question number 5, what is meant by fixed points on the scale of the liquid in glass thermometer? We had seen there is the marking lower fixed point and upper fixed point of the thermometer, just to read the temperature precisely. Okay, so you can see here option number A, the distance between the one scale division and the next. So it is not between the two scale divisions. Okay, it is not, there is no relation between two scale divisions, and it has nothing to do with the two scales. So option number A cannot be the answer. B, the highest and the lowest temperature that the thermometer can record. This also cannot be the answer. Even the we can have the marking of suppose 0 degree Celsius, 200 degree Celsius, and thermometer even can record -1 degree Celsius and 101 degree Celsius. Okay, that can happen. So there can be some lower or higher temperature the thermometer can record beyond this fixed point. So this cannot be our answer because we don't take any rough temperature upper and lower and upper fixed point. We take some particular fixed value. So this cannot be the answer. C is maximum and minimum depth to which the thermometer should be submerged in the liquid. So it has nothing to do with any depth of some depth or submerging into the liquid or anything like that. Option number D, the two agreed temperatures used for marking of the temperature scale. So this is our answer. These are just two markings made on the thermometer which can be used to precisely understand the temperature change. So this is our answer, option number D. We use specifically like we use marking of 0 to 100 degrees Celsius, okay, or minus 10 to 110 degrees Celsius on this scale. Okay, we use some precise fixed marking. So option number D can be correct. Now we will move towards the structural problems of the same chapter. So we will begin with the structural problems of the thermal properties and temperature. So we can read here question number 1 in the part A. State what is meant by the specific heat capacity of the substance. So we had learned the definition of the specific heat capacity. It is what? It is nothing but the amount of heat that we provide to the substance to change the temperature of that substance by 1 degree Celsius. Okay, and that particular heat we are providing to the unit mass of the substance. So unit mass can be 1 kilogram if you consider the SI system of unit, or it can be 1 gram if you consider the CGS system. So it can be anything. So we can write here the heat required to change the temperature of unit mass of the substance by 1 degree Celsius. 1 degree Celsius. Okay, so you can also write down, and instead of unit mass you can put the 1 kilogram also if you wish. So this is the definition. To change, you can also write down the increase in the temperature, but we can also use this definition for increasing and decreasing temperature. So better I can write down it change the temperature. So it is nothing but the heat required to change the temperature of the unit mass. This unit word is very important, of the substance by 1 degree Celsius. You can also write down 1 Kelvin, that can also be the correct one. The part B of the question, the student carries out the experiment to find the specific heat capacity of aluminium. He uses the electric heater and thermometer inserted into the separate holes in the aluminium block. The following data are obtained. The mass of the aluminium block is given, that is 2 kilogram. The power of heating element is given 420 watt. The time of heating is given, that is 95 seconds. Initial temperature of the block is given, that is 19.5 degrees Celsius. The final temperature of the block is given 40.5 degrees Celsius. And we want to calculate the value of the specific heat capacity of the aluminium given by the experiment. So this experiment is done where we have the aluminium substance here, and this aluminium we are going to heat it from 19.5 degrees Celsius to 40.5 degrees Celsius, and the mass of the aluminium is given, that is 4 kilogram, and basically the heater is used here to heat the aluminium block. You can see this electric heater is used, and the power of the electric heater is nothing but 420 watt. and the time it takes from to go from 19.5 degrees Celsius to 40.5 degrees Celsius is 95 seconds. So we want to calculate the specific heat